Welcome to Section 4, Secure Connections to the Cloud. In this section you will learn an introduction to cloud services for the IoT, Microsoft Azure's IoT services, Amazon Web Services IoT services, IBM Watson's IoT platform, and we'll have a hands-on lab connecting an IoT device to AWS. Secure connections to the cloud. In this video, we'll begin our look at cloud services for the IoT. Let's first talk about the current state of cloud and IoT. Today, many IoT devices use short-range RF protocols for communications. These devices often communicate with cloud services through some aggregation point, a gateway or mobile app for example. But with the coming introduction of 5G cellular technologies, we'll likely see IoT architectures begin to change as direct connectivity to the cloud begins to become an option for many more device types. Cloud service providers, or CSPs, were initially slow to support IoT systems. However, over the past couple of years, the big CSPs have begun rolling out more and more IoT services. This includes the inclusion of IoT protocol gateways, new APIs that support management, monitoring, and control of edge devices, event-based compute processing, and data analytics, both in the cloud and on the device, for example with AWS Lambda and Greengrass. Virtual shadows that store configurations even when an IoT device is offline, and even now pre-configured hardware to cloud, as seen in a partnership between AWS and Microchip recently. All of this points to the cloud being the global connectivity layer for the IoT and supporting even more new use cases as IoT devices communicate and interact with one another. The cloud removes geographic distance barriers that currently limit IoT device interactions. It allows for centralized placement of controllers that can reach out to industrial control systems, and it even supports the coordination of those control systems across vast distances. The cloud is also beginning to provide new security services for the IoT. CSPs offer identity management options for edge devices, firmware distribution services, asset management services, and even key and certificate management services. CSPs can also be configured to download log files and monitor actions within your IoT systems. And of course, from a system-of-system perspective, the cloud is the aggregation point for various data feeds that may influence the operation of an IoT system. Taking in weather feeds, pricing feeds, etc. for an agricultural operation can support automated decision-making as to what to perform various functions in the field, for example. Let's take a look at an example that shows the power of the cloud in bringing together functions across different industries. For example, a vehicle crash is detected and the cloud supports immediate response to the situation. First, a crash is communicated over DSRC or LTE to a crash management service in the cloud, perhaps something that the driver subscribes to. That crash management service acts as the centralized controller to task cameras in the location for footage and pass that footage to investigators and insurance companies, of course with privacy permissions in place. At the same time, emergency services are notified and immediately dispatched. In severe cases, the nearest hospital is notified, passed any data about the victim, and begins preparation. A tow service is automatically dispatched to the location at the same time. The insurance company is passed all connected vehicle sensor data, and an appointment is made with a local repair shop. At the same time, vehicles are routed around the accident to prevent a traffic jam. This is an example of the cross-industry use cases that will begin sprouting up as the IoT continues to mature. So this all means that we are at a time where security engineers have to be prepared to help IoT system architects that are going to be looking to devise new connectivity and collaboration layers. These layers may span an entire organization, an industry, or even cross industry boundaries. Today, we see that most edge devices communicate with the cloud using web sockets, RESTful Web Services, or MQTT. Other protocols are supported also via custom APIs or by tunneling them through a gateway. Data coming into the cloud may be in batches, or it may be a continuous stream. CSPs often have different interfaces, for example AWS Kinesis from the edge. Data can be messaging, video, imagery, etc. With a generic cloud, there are services that support processing based on events, messaging, search, notifications, etc. There are also compute services that allow you to specify actions to take on your data, and of course, there are many more advanced services such as machine learning, voice processing, and other data analytics. There are many CSPs to choose from. A quick sampling of some of the well-known ones include AWS, IBM Watson, Microsoft Azure, SAP HANA, Telit, GE Predix, and the Salesforce IoT Cloud. I include platforms such as ThingWorx and Xively here, as well as they operate cloud services for your IoT devices. As the IoT is connected via the cloud, there are many threats that have to be considered. For example, your common threats to your users and administrators are still relevant. If an administrator has his or her administrative password or key compromised, there can of course be severe repercussions on the IoT system. Virtual machines and containers in the cloud still need to be patched and locked down to mitigate the risk of an attacker gaining access. Networks, both virtual networks in the cloud and the wireless networks that your devices use to communicate with the cloud, must still be secured using encryption. And of course, you need to think through possible ways that an attacker can compromise an IoT edge device and use that as a jumping off point to the rest of your system. In our discussion of the cloud, it's probably also a good idea to mention the concept of the fog. The Open Fog Consortium put out fog computing guidance in 2017, and this diagram shows a visual representation of their guidance. At the bottom, you see the different types of IoT edge devices. These are supported by the fog layer, which includes trusted fog nodes that are likely loaded onto existing networking equipment, such as routers and/or switches, using various communication protocols. These fog nodes provide a first layer of data analytics, storage, and protocol abstraction. Fog nodes can also communicate amongst themselves through fog-to-fog opening up coordination and collaboration amongst multiple communities of interest. A fog management system provides additional support features that include IoT and node management, policy management, discovery and registration services, and additional analytics features. This layer provides enhanced management and analytics services for IoT edge devices. However, the cloud is still used for more compute-intensive analytics, long-term historical analysis, and long-term data storage.